Morning students. Today we are going to see geometric distribution. This is another kind of discrete distribution. Why? Because here also the random variable x, it takes discretely the values. Okay, first we can define its probability mass function. Yeah, random variable capital X is said to follow geometric distribution if it assumes values and its probability. What kind of values? Non-negative. That is very important. Assumes non-negative values and its probability mass function is given by P of x equal to x, that is equal to q power x into p. Here x, it takes the values 0, 1, 2, 3, etc. How we call this as probability of a random variable at x means P is the very first success after getting x failures. In this situation, we have to use the probability mass function like this, where q equal to 1 minus p, and p's value always lies between 0 and 1. A later form is there, that also we can define P of x equal to x, that is equal to q power x minus 1p. Here we have to take x values from 1 to infinity, the integers. There it is 0 to infinity, the integers. Either form can be used, both are correct. Here P is the first success occurring at xth trial. Here P is the first success occurring x plus 1th trial. Before all trial, we found only the failures. Where we can apply the geometric distribution, that we can see now by means of its application. It has a special important application in queuing theory. In queuing theory, related to the number of units, which are served for served or served or waiting to be served at any given time. So served or waiting to be served. x or x plus 1. Once the trial, get a success. Getting as a success. So this is the main application of a geometric distribution. Now we can derive its MGF, mean, variance and standard deviation. Derivation of MGF, mean, variance and standard deviation. MGF, mx of t, you know very well. It can be written by means of E operator E of e power tx. So when you apply the geometric distribution, there are two MGFs are there. Now I derive by means of one kind of PMF. You try with another kind, but both will give us the same answer. In MGF, slightly vary, but when you try to find mean and variance based on that particular MGF, you will get the correct same answer. Summation over x equal to 0 to infinity I. Okay. P of x equal to x. That is equal to summation x equal to 0 to infinity e power tx q power x. So x failures, after that very first success we get at its x plus 1 the trial. When you use such kind of thing, we get it as x equal to 0 to infinity q e power t whole power x into p. When you expand this summation, 1 plus q e power t plus q e power t the whole squared plus etc. This tend to infinity. It has the form of like this one, since 1 plus x squared plus etc. means we can write this as 1 minus x to the power minus 1. Here x we have q into e power t. So p into 1 minus q e power t whole power minus 1. In the later form, we can write this as p by 1 minus q e power t, or else we can write like this also, 1 by p by, So, when we write its reciprocal form, 1 minus q e power t by p whole power minus 1, that is equal to 1 by p minus q by p e power t whole power minus 1. So all the forms are correct only. Which one is easy to memorize for you, you can use that formula. Now by using the last derived format, I am going to derive its mean. Mean of x, which is nothing but e of x, that is equal to mu1 dash. Mu1 dash is nothing but mu x dash of t equal to 0. So that is equal to, when you differentiate this form at t equal to 0, we get it as minus 1, 1 by p minus q by p e power t whole power minus 2 into, when you differentiate the second term, minus q by p e power t. This comes. Okay. So minus of minus plus 1 by p, q by p is outside, inside 1 by p minus q by p. When you take this is LCM, p as LCM, q by p, 1 minus q by p, 1 minus q is nothing but p, these two are cancelled. So finally, mean is, what is mean? Therefore, mu1 dash, the mean of x is q by p. Now we have to derive its variance and standard deviation. Is this clear? Alright. Now we can move to its next derivation. variance. For getting variance, we have to differentiate mx of t two times and at a t equal to 0. Variance of x equal to mu2, that is equal to mu2 dash minus mu1 dash the whole square. So how can you derive it as mu2 dash, where mu2 dash equal to mx double dash of t at t equal to 0. So a one-time derivative we have in our hand. By using this, we can find its next time derivative. Q by P e power t 1 by P minus Q by P e power t whole power minus 2. It's one more time derivative at t equal to 0. You understood this step, everybody? Now we can find its one more time derivative. Q by P is constant. We can take it out. When you consider e power t is constant, you differentiate minus 2 1 by p minus q by p e power t whole power minus 3 into minus q by p e power t. Okay, so we derived the second term. Now you keep the second term as same 1 by p minus q by p e power t whole power minus 2 into, you differentiate e power t, it comes as e power t. Finally, we have to substitute t equal to 0. That is equal to q by p, it comes as 2 times of q by p plus it comes as simply 1. That is equal to 2q squared by p squared plus q by p. This comes. Okay, now we can simplify the format as like this. Therefore, mu2 dash equal to 2q squared plus pq by p squared. That is equal to q into 2q plus p by p squared. That is equal to q into 2q plus 1 minus q. Since p is 1 minus q. Now we can subtract it. 2q minus q is q. 1 minus q, this is q. Here it is 1 minus 1 plus q divided by p square. So what actually you get? P by, sorry, not p, q. q by p square plus q square by p square. Am I correct? This is our mu2 dash. Now we are going to find its mu2. Therefore, mu2 equal to mu2 dash minus mu1 dash the whole square equal to, what is mu2 dash? Q squared by p squared plus q by p squared minus, what is mu1 dash? Already we found q by p the whole square. Now these two things are cancelled. We get it as q by p square. Am I correct? Q by p square. This is the variance. Therefore, variance of x equal to q by p square. Now, standard deviation. Standard deviation of x equal to square root of variance of x, that is equal to Q root of Q by P. This is the standard deviation. Okay. Now we derived mean, variance and the standard deviation. Here one thing you have to note down as very important thing. What we have got the variance? Variance of x equal to 1 by p into mean of x. That is q by p square. Therefore, variance of x is always greater than mean of x in this distribution. But in binomial, can you remember what it is the relation? Mean of x is always greater than variance of x. Why? Because NP, what it is variance? NPQ. NP is always greater than NPQ. Since here Q is less than 1, here since P is less than 1, we are dividing by less than 1 value. Here it is, we are multiplying by less than 1 value. Okay, is this clear? Please note down this. Remaining we can see in the next class. Memoryless property and some property problems we can discuss in the next class. Thank you.